So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says maximum sum subarray of size at least k. The problem goes like, given an array ARR and an integer k, find the maximum sum among all the contiguous subarrays having a length greater than or equal to k. So it's greater than or equal to k and not k. That is awesome. Let's see a few of the examples. So we have this array and where k is 3. If we can choose the subarray like this, which is of length 3, then we get sum as 1. But for k is equal to 2 and this array, we choose all of the elements because it is greater than or equal to k. So the sum is 6 over here. And if we choose k is equal to 2 in the next example again, we can end up with this subarray with sum as -1. Cool. Simple. So with these things in mind, how can we solve this one? Like, what are the possible solutions? What are the possible approaches to this? Let me copy one of the example like this over here. Yeah, and you see I have k and I have an array. So one of the possible approach can be like, hey, if I can use 2 pointers like I to, not 2 pointers but and double iterations like I to j, where I can take from this point to this point and keep continuing from 0 to 2, 0 to 3 and so on. And once this is ended, I can go from 1 to 1 to 2, 1 to 3 and so on. So obviously I wanted a loop of I and j, so that is the reason I'm iterating each element, n elements, n times. So the time complexity would be n cross n or n square. There would be no space complexity, so yeah. But again, n square is not a very decent complexity, to be honest. Can we have a different approach which is more efficient? So yeah, what can we do over here? If I can pull this example out and if I can understand that, hey, what is going behind the scenes, I can know that, hey, I can choose 1. Again, I can choose -2 as well, but I'm short with k is equal to 3. So I can go at max till this point. And yeah, I can choose these characters. But in next iterations, I can choose these 3 characters. I can move, I can move my left and right pointers. Okay, how to move this left and right pointers? That is also a question. Shall I move left and right, or shall I move only right and then left? You see, whenever you are hit with such kind of questions, I often go back to the question what is asked out of it. So it says having the length greater than or equal to k. So it's not just equal to k. If it was equal to k, then I would move left and right both. But if it is greater than or equal to k, I am free to move right. And based on my needs, I can move left. So let's see the second example where each item is 1 and k was, I don't know what was k, 2. K was 2. Then I started from left like this and right like this. I moved just my right pointers again till this point, so that my range would become from 0 to 5, which would end up the sum to be 6. So like this, I'm just moving right pointers as of now, and then I move left pointer as I like. Okay, this is very vague thing, like as I like. What do you mean as I like? So as I like, I mean I wanted to be greatest. So I wanted it to be a greatest in terms of numbers. So I want a maximum number out of it. So let's take this example. If I'm taking this example like this with k is equal to, what is k? 2. yeah, case 2, I'll start it from left and right. As I mentioned, I'll just use left, and then as I like right, sorry, I'll just move right, and as I like left. So in the next iteration, you'll find my right to be over here. Now I am, this was with a size equals to 2, and this is size equals to 3. I am already exceeding this. I have an option to shrink the size. Can I shrink the size? Yes, I can. So should I shrink the size or not? That's a question. I can shrink the size, so I can, but should I? That's a question. Well, let's see. If I'm shrinking left, that means I wanted to shrink the last point. So this is my last. I wanted to take -4 into consideration and remove it. So the question I should ask, will removing -4 benefit me? And the answer goes yes, because if I removed -4, it will improve my sum. Now if I remove my last, my L and R would be like this, with size again back to 2, but sum is equal to -1. How come -1? -2 plus -1. This -2 and this -1. So this is where I take a liberty, where I can remove the last or not. So if I'm going forward again, I can I can put L as this, -3 as this, where my last is this point now. And again I'm playing the same song back again. So size is 3. Shall I remove or not? Will removing the last, and what is the last, you say? The last is -2, benefit me? And the same things we are going forward, and we can move on. So yeah, this is what it is, and obviously we will keep track of maximum sum we have found so far and written that. As you can see, with this approach, we have not used any of the space, but we have not used any of nested loops and such kind of operations. We are only incrementing from left to right. That means 0 to n. So our maximum time complexity can be only O of n. So this is our time complexity. And yeah, with that thing in mind, I believe this is a good point to start the code. So let's jump into the code now. I have an array A and a size element k. I wanted to have left and right for convenience. I will also take last for convenience as well. Initially my left is 0, right would be 0 as well, and last would be 0. Everything is 0 right of now, and I wanted to have a sum variable which would be initially 0 and max sum, which would be equal to sum. This max sum is something I would be returning in the end. Max sum, because it takes the ultimate scan. So ultimate scan, and this takes the current scan. When I say scan, it is just a fancy way of saying that hey, when I go through L to R, it stores max, and when I just keep track of the maximum overall, so it's an max sum. So yeah, to calculate sum, I'll just do I is equal to 0, I is less than k, I plus plus, and there we go with sum plus equals to a of I. Bluntly taking the first k elements, because that is the least we want. We wanted to start from k right now. So once I have a sum variable with place, I can do the hard parts. So this is the hard part where I start from k till the end. So if I'm starting from k, I would be sure that left is equal to k, left is equal to 0, right is equal to k, and right should be less than a dot length r plus plus, not I. Now, okay, I have left, I have right, and I wanted to take sum. So let's understand what the sum would be. Sum plus is equal to a of r, and here I understood what is sum. I accumulated the sum. There is also some character known as last. This is nothing but the last values which we have accumulated so far. Again, this is accumulated and not an individual value, so it is last plus equals to. So I am accumulating the last elements a of L. Cool. Sure, I am accumulating the last values. I am incrementing R. Shall I incrementing L or not? That depends. So I'll increment L, but shall I remove the last or not to calculate sum? That is question. How do I know that? So if by any chance last is less than 0, that means this is negative value. This will downgrade my maximum. That is why remove this. And how do I remove this? I just use sum minus equals to last, and once I use the last, I'll just reset it. Last is equal to 0, and that is awesome now. And once I did that, I'll just use max is equal to, or max sum is equal to, okay, I have not used mat.max of max sum comma sum. Yeah, awesome. So I'm using this over here. I can use it over here as well for all those elements which are not greater than, not lesser than, and thereon I keep on iterating. Shall I compile this one? Okay, there's something missing. This should not be comma but semicolon, so it should be something like this. Although we are assigning it over here, but again, it is not a big deal. L plus plus semicolon accepted, so there's nothing E here. So how many compiler errors are there? So R is less than or equal to length length. Cool. So it passed the sample test case. Let me submit it for rest of the test cases as well. So yeah, it got submitted for all the rest of the test cases. This followed a pattern of 2-pointer, and not to mention we are accumulating the last values and resetting it as well. So this follows a pattern of dynamic programming, where you do not compute again and again the elements. You store it within a variable or within a state and reuse it. So this was one of the problem, including 2-pointers and dynamic programming. For more such dynamic programming concept, or to start with a dynamic programming with a Kidane algorithm, click the video on your right, and I'll see you in the next one.